for the graph. Okay? Make sure it's reasonable for the graph. So, the first one we're going to look at is this problem. It says the number of cars in an elementary school parking lot changes as time passes during the school day. Each graph shows two possibilities of the ways the number of cars might change over time. So what this is saying, okay, this graph represents one school day at an elementary, the number of cars in a parking lot. This graph also represents the number of schools at a parking lot, in the parking lot in one day at an elementary school. What I want you to do, discuss what each graph might be showing. Okay, so you're going to come up with kind of somewhat of a story of what each graph is showing, and then pick the graph that you think best represents what happens in one school day at an elementary school. Okay, so discuss with somebody next to you for a couple minutes what each graph is showing, and then which one you would think best represents it. Okay. Okay, 3, 2, 1. Let's talk about what each graph might be showing first, and then after we talk about what each graph might be showing, then we'll come up with what we think best represents a day at elementary school. Lucas, what's the first graph show? Yep. Oh, this is cars at elementary school. The same thing for both. Cars at an elementary school. So what does this first graph show of cars at the elementary school in one school day? Anybody else? Okay, so what do you mean? Okay. What time of day is this? That's lunch, right? It's right in the middle of the day. This is one school day. That's what it says. It's one school day. Okay? So this would be morning, this would be end of the day, this would be lunch, because this represents one school day. So what is this showing then? Rory? Okay, that's exactly what it shows. Please pay attention. It shows there's some people that get here and then they stay there all day. Who are those people probably? Probably teachers or people that work at the school. They get there, they stay there all day because there's that level, at least that level amount of cars the entire day. And then in the middle of the day, there's a lot of people that come to school and then leave the school. So maybe it's like a kindergarten where there's half days. Okay, so the morning students get picked up and the afternoon students get dropped off, and then those cars leave. Okay? Okay, it could be that. Okay? It could be that. Parents eat lunch with you day. Okay, now, graph 2 shows what then? Jonah?
Like in the morning they drop us off and then everyone stays and then after school they all leave.
Okay, so What cars stay at the school? People who work at school, right? They stay there all day. Well, elementary though, teachers, people, they leave their car there too.
No, I know, but not high school.
This is an elementary school. Says elementary. Brendan?
Well, it should actually, when there, it should actually spike up,
A little bit.
yeah, like it should spike up because of the parents dropping them off.
Okay. I think what they are saying here is that okay, but here's the thing. Is it going to be perfect? No, it probably isn't perfect. But what they're saying is maybe most of the students get dropped off by a bus, so there aren't as many cars there. But then these cars are the cars that stay there all day, so that's like people working at the school, and then after school is done, all the cars leave the parking lot. Okay, Emily?
It says people might think like people that actually park. Some parents just drive up,
Yeah.
drop your stuff, and then leave. So they
Very good.
count for that.
Parking.
They might see that for
Okay? Very good. Yeah. It's not parking in there. Okay? Very good. Okay, so I would say graph 2, I think, best represents what happens at an elementary school. There's a bunch of cars that stay there all day for people who work at the school and then leave at the end of the school day. Okay? Then, what we're going to do today is we're going to have some descriptions, and we got to pick a graph that best fits each description. Now, before we choose the graph, you have to describe what the variables are, what two things it's talking about. Okay? And we have to pick which one is independent, which one is dependent. Independent is always used with which variable? Independent is always X. Dependent is always Y. Alright, so this one it says a skateboarder rides down one side of a half-pipe ramp and then up the other side. Her speed changes as time passes. Okay, so here's the skateboarder. Here's the skateboarder. Here's what a half-pipe looks like if you don't know what a half-pipe is. They're going to go down and then up to the other side just once, okay? Now, before we pick a graph, you have to choose the variables. What two things is this talking about?
Going up and down.
What two things is this talking about? Speed and time. It's talking about the skateboarder's speed and the time that they're skateboarding. Okay? Which one depends on the other, speed or time? Time depends on what?
speed depends on time.
Speed depends on time. So, because speed is dependent on time, that means speed is the dependent variable. And then time is independent. You have to be able to determine which is an independent variable and a dependent variable in any situation. Okay, which one is changing because the other one is causing it to change. Okay, now we choose the graph that we think best fits. When we think about this situation, when the skateboarder starts this, how fast are they going?
Really fast.
How fast are they going right now?
Oh.
0. So our graph has to start at 0. So any graph that does not start at 0 can't be one that we can use. So graph 2 doesn't start at 0, we can't use graph 2. Graph 3 doesn't start at 0. Graph 5 doesn't start at 0. We can't use any of those 3 because it has to start at 0. Now, what's going to happen when the skateboarder goes down the half pipe? Speed is going to increase pretty quickly. Then what's going to happen when it goes up the other side? decrease pretty quickly. Which one shows increase quickly, decrease quickly? 6. Okay? Questions? First thing you have to do, Brendan, put that away. The first thing you have to do, determine which one is independent, which one is dependent between your two variables. After that, then you choose your graph. Okay? Let's look at the next one. The water level changes over time when someone fills a bathtub, they get in and take a bath, they get out and empty the tub. Okay? So, independent, dependent. What is our independent variable? What is our dependent variable? Water level and time are your two variables. Which one is which?
Water is dependent and independent.
Good. The water level is dependent on time. So water level is dependent. Independent is time. Okay? Now, first of all, does it start at 0 or does it start somewhere else other than 0? So it has to start at 0 because the tub is empty to start. So anyone that does not start at 0, we cannot use again. Okay? So now you're between 1, 4, and 6. They fill the tub up, they get in, they take their bath, they get out, empty the tub. Amanda?
Yeah, it's 1 because they fill it up and they get in and it rises a little bit and then they empty it.
Very good. When it's filling, because it's a straight line, what is that telling you? It's constant. Very good. It fills at a constant rate. When it's a straight line, that means it's filling at a constant rate. It doesn't fill really fast and then fill slow. It's constant rate. Okay? Then they maybe, at this point, let it warm up. Okay? Or cool down, because it's too hot. Sorry. Okay, then they get in, so the water level rises. There's more volume. They take their bath. They get out. And then what happens here? Drains at a constant rate because it's a straight line. Okay, very good. So graph 1 is going to be your best one there. So what you're going to do next is you're going to look at the next two, do them just like we did together as a class. Do them with someone next to you, please. Determine the variables. And then pick the best graph. What is that? says the number of hours of daylight. The number of hours of daylight changes over time as the seasons change. So first we have to determine our variables. Independent variable and dependent variable. Okay? The daylight hours is dependent on the seasons. Okay? Now, which one? First we have to think. Is there ever a time throughout the year where we have 0 hours of daylight?
In Alaska.
We are not in Alaska. Where we live right now, do we ever have a day where there are 0 hours of daylight? We do not. We do not have a time where it is at 0. So, that means you should be able to cross out any graph that hits 0. This one hits 0, can't use it. This one hits 0, can't use it. This one might be okay. This hits 0. Graph 6 hits 0. Graph 5 doesn't quite hit 0, but it gets very close. I would say not graph 5 because we do not have a day where we only have 1 hour of daylight. We have at least a good number of hours of daylight throughout the entire year. It's just that it does fluctuate a couple hours here and there. Okay? So that means graph 3 is going to work. This means okay, maybe this is spring. Most hours of daylight happens in the summer. Then we go to fall. Least hours of daylight in the winter. Spring, summer, fall, winter, spring, summer, fall. Okay? Seasons are changing. Hours of daylight are changing. Okay? The last one. Independent variable. Dependent variable. Independent's always